Hej og velkommen til vores spændende webinar i dag. Mit navn er Oliver Anstrøm, og jeg sidder som produktchef her hos Væksø med blandt andet ansvar for Festo. Og med mig fra Festo har jeg Jesper Fangel som sædvanligt. Velkommen til dig, Jesper.
Mange tak for det, Oliver. Jeg har glædet mig meget til i dag. Dagens emne er jo pneumatisk versus elektrisk drevne bevægelser. Og mere konkret, hvornår man med fordel kan anvende den ene form for løsning, og hvornår man med fordel kan anvende den anden form for løsning. Og det vil blive underbygget med nogle konkrete eksempler af min kollega Roland Folk, som er en af Festos specialister inden for energieffektiv automatisering. Rolands præsentation vil foregå på engelsk, og den starter lige om lidt. Han vil blandt andet komme ind på at runde kriterierne for, hvornår man med fordel kan anvende den ene eller den anden løsning.
Ja, det er korrekt. Man kan sige helt overordnet, så er der er tre kriterier, som man typisk vil kigge ind i. Det første er jo selvfølgelig, når vi skal vælge en teknisk løsning, så er det jo, hvad har vi rent faktisk af tekniske krav til den her løsning. For der er jo nogle forskelle på pneumatik og på elektrisk automation, som Roland Folk selvfølgelig kommer ind på her senere. Nummer 2, det er prisen. Og der er jo en indkøbsforskel i pris på de to teknologier. Men for at få et lidt mere realistisk billede af det hele, så vil man simpelthen nødt til at kigge på en TCO, altså en Total Cost of Ownership over et par år, for at se, hvornår giver det mening at bruge den ene løsning, og hvornår giver det mening at bruge den anden. Og så til sidst kan man sige, som der hører lidt ind under TCO'en, det er jo også energioptimering. Altså hvor meget energi bruger vi, hvor meget CO2 udleder vi. Det er der jo selvfølgelig noget politik i, der er noget PR i det, så det er jo noget, der fylder meget hos os alle sammen i dag.
Det er fuldstændig rigtigt, Oliver. Og du og jeg vil jo efter Rolands præsentation lige ganske kort slå en krølle på dagens faglige emne, og derefter, traditionen tro, havde jeg nær sagt, slutte af med en forfriskning. But first, a very warm welcome to you, Roland.
Yeah, thanks a lot, guys, and welcome here from Germany, from the Festo headquarters. My name is Roland Folk. I'm the expert for energy efficient automation here in the company. And in the next 50 minutes, I will give you some information about the comparison between electric versus pneumatic. There are a lot of discussions for these both technologies. What is the better way? What is the most efficient way? And I will give you some tips and tricks about this. Headlines like this, I think you all have seen in the daily newspapers. But what is the truth? Is it really true that the air is out? And if you want to have more efficient systems, you have to replace pneumatics by industrial linear motors? We will see. A daily comparison has a lot of phases. But mostly, if you see in the daily newspapers, the focus is on the energy consumption. Only a few takes a look to the costs, especially the investment costs, and also the techniques, the productivity and the environment. First of all, I will give you some information about compressor systems, because this is the energy for pneumatics, and so we have to take care for the generation of compressed air. And I think a lot of you have this diagram, this energy diagram on the left side here in mind. So this means 100% of electrical energy you put in a compressor. At the end, we have 7% less directly on the machine. This was valid for a long time. This was created in 1994, but it's not unique. It's a wrong argument here. And we know since around about 10 years that a compressor is much more efficient than we will see here on this diagram. Here, a modern system with a 64 kilowatt machine, 64 kilowatt compressor, 100% in. We have our losses in the compression, in the preparation, and so on. But at the end, we have round about 42% remain on the machine. This is part of theoretical. In most cases, the degree of efficiency from a compressed air system is around about 20 to 25%. I have a lot of discussions with our customers about the technologies, and they ask me mostly, what is the better way? What is the most efficient way? So my answer is the application is the key. and we tried to figure out some key questions to choose which is the best technology for the application. And you see here these 5 questions. So, do we need a free and flexible position? Are there long strokes with high speed and short cycle times required on the machine? Do we need more than 3 positions in our application? Or have the drive more tasks than clamping or holding? And last but not least, is a smooth motion required on the system? If we can answer all questions with no, a pneumatic drive seems to be the best solution. If one answers yes, we have to think about electrical or servo-pneumatic drive system here. Because both technologies have their strengths and also their weaknesses. I will start on the electrical side. The strengths on the electrical system, we have a flexible operational profile. We can easily adjust the drive system. We have really high stiffness, high dynamic movements, much more higher than pneumatic systems. And in our case, we have a low dependent use of energy. So depends how many weight is on the drive. This is the result then for the energy consumption. A pneumatic system always takes the same energy. If you run the cylinder with a high load or with no load, every time the same, the volume for the drive has to be filled. The strength is on the pneumatic system. It's easy and cost efficient. We have a low maintenance, normally high degree of protection, especially in X areas where we have to spend a lot of money for electrical systems. There's no problem with the pneumatic system. Then absolutely advantage, we have high density, so a small required space. We have a lot of force on a small space in the machine, easy installation and setup, and 100% overload possibility. The weaknesses on the electrical side, it's really complex, the system design. We have a limited overload capability. We have a high required space, a high investment. We're talking at the moment about a ratio between 1:4 up to 1:8 between a pneumatic system and an electrical system in the same application. And don't forget, we have a decentralized heat generation on the electrical system. So each motor, each controller is generating heat directly on the machine. A pneumatic system is generating the heat at the compressor. And this heat, this amount of heat we can use in a heat recovery system. Direct to the machine, there is no chance to have a heat recovery system. The weaknesses on the pneumatic side, we have this image of a high energy consumption. As I mentioned before, for each stroke, the cylinder takes the same volume, so the same amount of energy. We have these energy losses with leakages. I hear it, I don't know how many 100 times. And pneumatic system is not completely sealed. I think you all know this. We also know it, but we are talking here about leakages in the amount of 1 to maximum 5 liters per hour. A leakage you can hear will start at 2 liters per minute. And this is a really high range. And so forget these leakages in the system. The leakages, yes, on the connectors, on broken tubes, they're still alive, but this we can fix very easily. Then we talk sometimes about noise emission, the exhaust air, the movements without inclined positions. This means only moving from A to B, and the lower stiffness in comparison to the electrical drive. Yeah, and if we take a look to a drive system, electric or pneumatic, the best case is to have a holistic evaluation of the life cycle costs. So it means TCO, total cost of ownership, or LCC, life cycle costs. And this includes the acquisition costs, the energy costs, the cost for the installation, the cost for the commissioning, the implementation efforts, so the time, the know-how you and your colleagues need, the maintenance, and so on. But the reality is, a lot of the current approaches, they are focusing only on one criteria, as I mentioned before, mostly the energy consumption. Well, let's have a look to some use cases. I think it's clear. Everybody wants to have his application, his solution at the best system. So the competitor use cases are tailored mostly to their favor. And if we see it here on this YZ gantry, the operational data, it's 1.5 seconds of cycle time, 24 hours a day, and 360 days a year, typically for food industry, packaging machine. They're running with this cycle times and this duration. The cost you can see here, this is typically for Germany. At the moment in industry, we are paying between 15 and 18 euro cent per kilowatt hour. And so with a modern compressed air system, around about 2 euro cent for a normal cubic meter. In Denmark, the prices are less than in Germany. I checked it, and you will pay around about the half what we have here in Germany for energy costs. But let's have a look for this calculation. We have here the pneumatic system. It's cheap in investment. It's around about 1,000 euros, but we have really high energy costs during the lifetime because of this really short cycle times. The electrical solution, it's much more expensive, around about factor 5 here, but the energy costs are less than the pneumatic systems, and so we have a return on invest around about 2.5 years later, and from this point we can save money for the company. It's clear, there is no discussion or nearly no discussion which system is here the more efficient. But if we change the cycle time from 1.5 to 3 seconds, also 3 shifts per day and 360 days a year, then what happened? We have completely different curves. The system, the pneumatic system, is much more cheaper in invest and also for the energy costs. And so I think there is no discussion. You change only one point in the application and completely different result. Yeah, some more applications now from the automotive industry. A screwing station, we have to move 5 kilograms here on front. The cycle time is around about 53 seconds, and the travel time for the cylinder is between 1.5 and 2.5 seconds. We have a 3-shift operation, 300 days a year, and the compressed air cost is only 1.5 euro cent because the customer has his own power plant. So the electricity is really cheap. You see only 10 euro cent per kilowatt hour. We've calculated 3 different systems. A pneumatic system with a classical cylinder, 32 millimeters bore, 50 millimeters stroke, and the accessories, so the valve, the throttle valve, the tubes, and so on. Acquisition costs around about 180 euro. Then 2 electrical systems, one with a servo motor and one with a stepper motor. You see 3,000 euros and 1,500 euros roundabout for the electrical system. The ratio much more higher. We're talking here about 1:8 and 1 something. And the cost evaluation, the invest for pneumatics 180 euro. The energy cost is around about 10 euro. The electrical system, 3,000 euro. The energy costs are doubling. Here, the energy costs for pneumatics. I will describe why. And the stepper system, it's the energy costs around about 1/3 of the pneumatic system. Especially on the servo, we have really a long cycle time, but the movement is only 1.5 to 2.5 seconds. So this means 50 seconds we are in standby with the electrical system. An electrical system in standby have an energy consumption. The controller needs energy, the power supply needs energy, and it's much more than a pneumatic valve, which is in standby and activated. In a standard motor controller, we're talking about 15 to 20 watt hours consumption, and a pneumatic valve, it's 0.5 to between 0.3 and 0.5. And this is why the energy consumption of the servo system is much more higher than pneumatics. And if we see the diagram here, I think you agree with me, these lines never will hit in the next 20 or 25 years. Another application, it's a transfer system. You can see it here. We're picking parts from this side, 1.8 meters vertical and then 4 meters horizontal and down 1.8 meters to another conveyor belt. 1.5 kilos, the cycle time is 23 seconds and the travel times horizontal 5.5 and the vertical 2.5 seconds. Same boundary conditions, and the calculation here, you can see the pneumatic system is 5,500 euros and the electrical system is 9,500 euros only investment. And here we have the cost for energy. We have now 1,700 euros for the pneumatic system and only 117 euros for the electrical system. So after 3 years, the electrical system is paid. And I think here's clear. I will choose the electrical system here. Yeah, and at the end, I will show you a live demonstration, pneumatic versus electric. We have here a demonstrator, the electrical drive. It's a 100 millimeter electrical drive with a tooth belt. And on the right side, it's a pneumatic drive, also with 100 millimeters. They have nearly the same force. And we run this two drives in 3 different movements. First of all, is a movement without any load, 3 times. Then pneumatic system, 3 times. We'll zoom in that you can see the values later. Now we are running with a load of around about 10 Newton. And at the end, we have here holding a mass with around about 55 Newton. So the pneumatic system is pressing against the electrical system. Now we are changing. The electrical system is pressing against the pneumatic system. And if we take a look now to the values, the linear movement without any load, electrical system, it's 25 watt seconds. Pneumatic system, it's 78, 3 times more, with a load of 10 Newton, 26 to 21, and now. Pneumatic system is pressing the electrical system and it's increasing the energy consumption 240, and on the other side, the pneumatic system has the force inside when it's activated. Holding, pressing, clamping, these are the advantages for pneumatics and movements with long strokes and short cycle times and lower force. This is the advantage of the electric system. A short overview of pneumatic versus electric. I hope I have given you some tips and tricks. And if there are questions, please ask. My contact data you will get from Jasper. And have a nice day. Bye.
Thanks a lot, Roland, for your very interesting presentation. Som man tydeligt kunne høre her, så er der jo masser af applikationer både til elektriske løsninger og til pneumatiske løsninger. Og det er den konkrete opgave, som afgør, om det er det ene eller det andet, der er det mest optimale. Og for at man overhovedet kan finde ud af, hvad der er den mest anvendelige løsning og den bedste løsning, så bliver man jo faktisk nødt til at lave en TCO-beregning.
Korrekt, ja. Som I kan se her på den her PowerPoint, og som Roland så fint var inde på, så er der jo en masse kriterier, man kan bruge til at udvælge, hvilken løsning man har brug for. Derudover så har Festo også lavet den her meget fine, man kan sige, det er meget fint diagram, hvor du kan gå ind og se, hvad er fordelene for den enkelte løsning, altså den enkelte teknologi, inden for et par forskellige kriterier. Og den kan egentlig hjælpe en lidt med at komme i gang med, hvad man skal vælge. Den er selvfølgelig frit tilgængelig. Udover alle de her løsninger, vi snakker om i dag, så er det også lige værd at nævne, at Festo jo har det her meget, meget udmærkede produkt, der hedder Simplified Motion Series, også SMS for kort. Og det er jo en komplet enhed, hvor man har en elektrisk akse med en indbygget motor og en indbygget lille stepperdrev i. Så man har faktisk en komplet enhed, som er utrolig fleksibel og som er meget kosteffektiv kontra de gængse, man kan sige, elektriske automationsløsninger, der findes på markedet i dag. Så det er et super fint alternativ, som lidt en mellemting mellem pneumatik og de gængse servoløsninger, der findes. Og vi har lavet, sidste år, der lavede vi et webinar, hvor vi specifikt fokuserede på det her produkt. Så det kan man gå ind og gense, eller se selvfølgelig for første gang på vores YouTube-kanal. Man skal bare søge efter Væksø inde på YouTube. Ellers er I selvfølgelig altid velkommen til at tage fat i os, hvis I vil vide mere om det her. Og så hjælper vi jer selvfølgelig i gang med det. Til sidst så er det lige værd at nævne, at Festo har selvfølgelig en masse lækre gratis værktøjer. Og blandt andet så har de også den her TSO-beregner, som så man kan bruge til at sammenligne pneumatik med en Simplified Motion-løsning. Og der har man simpelthen mulighed for, når man logger ind med sin egen bruger, at gå ind og kigge, hvis jeg nu skal have noget, der kan løfte så mange kilo, så langt, og vores pris for en kilowatt-time, den er det. Hvad koster den ene løsning, så kontra den anden løsning? Altså, hvad koster en pneumatiske løsning, komplette løsning, kontra Simplified Motion løsning, og hvor meget koster de hver især i strømforbrug, og hvor meget CO2 forbruger de begge to. Og det bliver så en total cost of ownership, altså en TCO-beregning over 4 år, man faktisk får smidt i ansigtet lige der, uden man egentlig behøver at fylde alt for mange informationer ind. Så den er god ligesom til at bruge til inspiration til, okay, hvor stor udsving er der fra elektrisk til pneumatisk. Det var så det for den faglige del for i dag. Og nu kommer Jesper her, kan jeg se.
Det er nemlig rigtigt, Oliver. Det er en servitrice her.
Det ser godt ud.
Vi håber, I har fået noget nyttig viden og nogle idéer med, som I kan bruge fremadrettet, når I sidder og konstruerer og vælger løsninger, om det skal være pneumatiske eller elektrisk drevne bevægelser. Det næste, vi skal i gang med, det er dagens smagsprøve, faktisk dagens forfriskning. Men inden da, så vil jeg lige sige, at efter webinaret, så vil I modtage en e-mail fra Væksø, hvor I har mulighed for at give os jeres feedback på dagens webinar. Og udover det, så kan I indtaste jeres navn og adresse, så vil I efterfølgende få tilsendt en smagsprøve også faktisk. Så Oliver, skal vi tage lidt hul på forfriskningen?
Lad os prøve at se på det. Ja, det vi skal smage, det er faktisk en gourmetsaft fra Rebel, som er produceret af Rebels egen sommelier, Morten. Og den er udviklet i samarbejde med nogle af de bedste restauranter og øvrige sommelier i landet. Og den er nøje udvalgt frugt fra nogle af de bedste frugtavlere i Danmark og gartnerier. Og det er jo et alkoholfrit alternativ til rødvin. Hvis man ikke er så glad for alkoholfri øl for eksempel, så kunne gourmetsaft faktisk være et godt alternativ. Og den vi skal smage i dag, den smager af kirsebær, kan jeg se, blommer og hibiskus. Og I kan se, at vi har faktisk fundet et par små vinglas frem, og det er fordi, den anbefalede at blive brugt i et bourgogneglas. Det er så ikke helt det, vi har i dag, men det var den næstbedste, vi kunne finde. Ja. Så lad os prøve at smage på den.
Det er bedre end de tandkrus, vi normalt bruger, Oliver.
Ja, det vil jeg sige. Ja, det dufter i hvert fald super lækkert. Og egentlig også en flot farve, som man tænker over det. Lad os prøve.
Lad os prøve en gang, Oliver.
Se om det går an som alternativ til blandt andet rødvin, måske. Skål.
Skål.
Skål ud.
Skål. Hold da op, det er saftsusen lækkert.
Det smager dejligt frisk, vil jeg sige. Det var faktisk, det var ikke bare almindelig saftvand, det kan man faktisk godt smage.
Det kan I glæde jer til.
Ja, husk lige, når vi sender den her spørgeskema ud, og lige indsætte jeres information, fordi så får I selv mulighed for at smage sådan en her lækker flaske her. Ja, så den er god til, når man skal køre, vil jeg sige. Det kunne jeg godt forestille mig.
Absolut, ja.
Tak for i dag, og jeg håber, at vi ses til vores sidste webinar i år, som der bliver her en gang inden jul. Så hold jer opdateret, så kommer der nærmere omkring det.
Mange
Tusind tak for i dag. Ja.
Hej.
Og tak til dig, Jesper.
Ja, i lige måde, Oliver. Skål.
Tak. Skål. Hej. Lækkert.
Det smager virkelig godt, det må jeg sige.